फैकल्टी मेंबर से रिक्वेस्ट रहेगा कि वीडियोस ऑन करके रहें। फैकल्टीज मेंबर जितने हमारे डिपार्टमेंट के हैं सभी से मेरा रिक्वेस्ट रहेगा कि सभी वीडियो ऑन करके ही रहे इनॉग्रल तक कम से कम। हरीश सर वेलकम।
नमस्कार सर, कैसे हैं?
बस एकदम बढ़िया हूँ मैं, आप ठीक हो?
हाँ जी सर, मैं बिल्कुल ठीक हूँ।
चलो बहुत बढ़िया।
इंतजार है सर आपकी वर्कशॉप का।
हाँ बस एक 2-3 मिनट समय ले रहे हैं और
ठीक है,
डायरेक्टर साहब की भी मैं वेट ही कर रहा हूँ।
हाँ
बात हो गई, बस डायरेक्टर साहब आते ही हैं और हमारे ऑनरेबल स्पीकर साहब भी आ गए हैं।
अच्छा
शर्मा सर गुड मॉर्निंग।
शर्मा सर गुड मॉर्निंग। गुड मॉर्निंग।
गुड मॉर्निंग।
शर्मा सर आप म्यूटेड हैं, आप अनम्यूट करके।
मैं बात करता हूँ सर बात।
हाँ
गुड मॉर्निंग सर।
गुड मॉर्निंग बेटा।
गुड मॉर्निंग सर।
गुड मॉर्निंग मैं तो हरीश सर हम बात करेंगे थोड़ा बाद में कॉल पर, वो सेमिनार कॉन्फ्रेंस जो लेनी है ना एक हमें नेशनल लेवल पे, उसके बारे में बात करेंगे। पहले आप स्वस्थ हो जाओ अच्छे से।
बिल्कुल सर बिल्कुल
करेंगे, उसको करना है। हो गई मेरी उनसे भी बात हो गई है और उसमें
अच्छा।
दोनों को मिक्स करके, हाँ मेरी वहां पर भी बात हो गई है।
बिल्कुल सर।
अरुण सर थोड़ा ग्रुप पे डालो ना, वी आर वेटिंग ज्वाइन इमीडिएटली। हमारे सब बच्चों के लिए बोल दो कि ज्वाइन, मैंने डाला है अभी ज्वाइन, एक और बार बोल दो उनको जरा, सभी बच्चों को ग्रुप पे, व्हाट्सएप ग्रुप पे ज्वाइन इमीडिएटली। Already we have 11. Can we start, Ankit sir?
सर एक मिनट बस मैं
ओके लेट मी नो। डायरेक्टर साहब को मैं कॉल करके बुला लूंगा। हारिस, मोहम्मद हारिस। हाँ बेटा, बाकी आपकी क्लास।
जी सर, गुड मॉर्निंग सर।
गुड मॉर्निंग बेटा। आपकी क्लास के सब बच्चों को ज्वाइन होने बोलो। ऋतिक, आप अपने
ओके सर।
बच्चों को ज्वाइन होने के लिए बोलो। आदित्य,
हाँ सर, सब आ गए हैं ज्यादातर।
हाँ, इमीडिएट ज्वाइनिंग। ओके, वी हैव टू स्टार्ट। अंकित जी, अंकित सर,
शर्मा सर।
शर्मा सर ज्वाइन हो गए हैं?
हाँ, ज्वाइन हो गए सर का, अभी ऑडियो ऑफ आ रहा है।
अच्छा अच्छा अच्छा, उनको ऑन करने के लिए रिक्वेस्ट कर दो।
Yeah, good morning. I am here.
हाँ,
ओके सर,
ओके,
गुड
गुड
मॉर्निंग।
मॉर्निंग सर, गुड मॉर्निंग।
Can you hear me?
यस सर, वेरी ऑडिबल।
We are waiting for our director sir to join. Within a minute he will be joining, sir.
Okay, no issue.
अंकित जी, डायरेक्टर साहब को फोन करो ना, मेरा फोन हैंग हो रहा है।
ठीक है सर, मैं कर रहा हूँ।
एक मिनट, फोन हैंग हो रहा है। हेलो सर,
सर हो गई?
डायरेक्टर साहब से बात हो गई? अंकित जी?
जी सर, जी सर।
हाँ, डायरेक्टर साहब ज्वाइन हो रहे हैं।
सर बिजी जा रहा है उनका फोन अभी,
किसका? मेरा?
डायरेक्टर सर का।
अरे यार, वो एक्चुअली मैंने कॉल किया तो बाद में वो कॉल कट नहीं हुआ, चक्कर ये हो गया, तो इसी कारण से थोड़ा सा प्रॉब्लम आ रहा है, मेरे को लगता है उनका।
सर कट कर दिया, इसका मतलब ज्वाइन हो रहे हैं सर।
हाँ हाँ हाँ, कुछ प्रॉब्लम आ रही है मेरे फोन में। अंकित जी, आप कांटेक्ट करो सर को।
सर मैंने कॉल किया था, सर ने फोन कट कर दिया, इसका मतलब ज्वाइन हो रहे होंगे सर।
जी जी। Dear participants, we are waiting for our director sir to join. Sir, please, 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 please. He will be here within a minute. and we will start with. Already we are late by some 7 minutes, no problem. Directors has joined. Yes. Thank you, sir.
Good morning, everybody. Good morning, Professor Jain.
Good morning, sir. Good morning. Okay, let us start. So, on behalf of Civil Engineering Department, Faculty of Engineering and Computer Sciences, I welcome you all for this particular workshop on mixed design, concrete mixed design. First, I welcome our beloved director, Dr. Rakesh Ji Dwivedi. I welcome today's speaker, Mr. Om Prakash Sharma.
Thank you.
I welcome my faculty members and participants, all dear students. Now, sir, today's topic is on mixed design concrete.
आवाज नहीं आ रही है जन साहब।
Okay, there is some electricity problem. I am audible to all?
Yes.
Now you are audible.
Yeah. Some electricity issue was there. Okay. Director sir is there?
Yes, sir. I am here. I'm connected.
Same problem we are facing, sir. Electricity problem. Okay. So as we know that mixed design of concrete means what? We have to select the proper proportion of concrete ingredients. Now, what are the various? We have to select the proper ingredients. We have to select the proper ingredients of cement, aggregate, and coarse aggregate and fine aggregate. And it should have proper proportion of water also. Why it is needed? Because we know that the total strength of concrete depends on mixed design. So it plays a very important role in the life of civil engineer, particularly who are dealing with concrete. अब मैं स्टूडेंट्स की भाषा में बस 1 मिनट में अपनी बात समझाना चाहूंगा कि जैसे हम डेली भोजन करते हैं, भोजन करने में पर्टिकुलर चीजें क्या रहती है? एक दाल, सब्जी, चपाती, चावल। अब यदि हमारे को यही चीज चॉइस की है और हमारी मम्मी डेली ये सर्व कर रही है, हम खा रहे हैं, तो दिन भर हमें कैसा लगता है? हाँ, वी हैव सेटिस्फैक्शन, हमने खाना खाया, सेटिस्फैक्शन। सपोज ऑल ऑफ अ सडन अ डे योर मॉम टेल यू दैट कि आटा नहीं है, तो आज आपको सिर्फ चावल खाना है और दाल खानी है। सो व्हाट विल हैपन? आप बिना मर्जी के खा तो लेंगे, मगर होल डे हाउ यू विल बी फीलिंग कि यार मुझे आज प्रॉपर भोजन नहीं मिला, तो मुझे अच्छा नहीं लग रहा। सेम थिंग इज विथ कंक्रीट में जितने इंग्रेडिएंट्स हैं उतने रहना ही चाहिए, उतने रहेंगे तो प्रॉपर स्ट्रेंथ मिलेगी तो लाइफ लॉन्ग वो हमें स्ट्रक्चर साथ देगा। और जब लाइफ लॉन्ग साथ देगा तो क्या होगा? जो इकोनॉमी, जो भी खर्चा हमने आज किया है, 50 लाख, 1 करोड़, जो भी उस स्ट्रक्चर को बनाने में हमने खर्चा किया है, it will provide us its desired life of 60-70 years. So what will happen? That structure will be most economical. Suppose we are failing in mixed design, then what will happen? The structure is going to fail before the desired life. So whatever investment we have done for say 50 lakhs or 1 crore for that particular house, that structure will not be lasting for 65 or 60 years, whatever is the desired life. It may be failing in 30, 40 years. So what will happen? We will be on losser side. Okay, so this is the importance of mixed design. और हमारे पास तो बहुत ही एक्सपर्ट हैं आज श्रीमान ओम प्रकाश शर्मा सर, मैं उनका स्वागत करता हूं और उनसे हमको बहुत कुछ सीखने मिलेगा. Now I invite our beloved and respected director sir for his welcome speech and inauguration of this particular workshop. Most welcome sir, most welcome. Dr. Rakesh Dwivedi.
Thank you, Dr. Jan. You really set the background very, very effectively. My sincere welcome to Shri Om Prakash Sharma ji, who is the Managing Director of QTech Ready Mix Concrete, which is located in Jaipur. So he is the resource person of today's session. My audibility is okay? Fine.
Yes,
Yes,
you
sir.
are audible.
Yes.
Okay. So we welcome you, Mr. Sharma.
Thank you, sir.
And I'm thankful that you have accepted our request and expressed your readiness to deliver the talk in this huge full topic, mixed concrete design. In fact, we usually teach our students 5 basic characteristics of a mixed concrete design, that is American method. In fact, in modern concrete design, that is widely taught by the professors of civil engineering. Many people have accepted this mixture. Basically, this is a mixture model.
Yes.
All right. Then another one is graphic method, which is technically more viable. I'm not going in detail. This is just my informatory knowledge, basic informatory. So another one is this graphic method, and then Indian standards have come. That Indian standard methods of mixed design, and there were many tables are available and many measurements and many things. We usually map. Our resource person will go in detail and he will let us know the recent trend of this concrete mixed design. This is a mixture model usually, and Indian people are very much liking this mixture model. And this is giving a strength, as Dr. Jain has narrated in his address. If you are taking a complete diet, your strength would be higher side. So it is simply creating some kind of mixture model, which is giving the strength to your infrastructure and giving the longevity too. So then Indian standard methods are also existing, and we are using, in fact. Then there is one institute in America. In fact, all civil engineers are knowing about the American Concrete Institute, which is basically defining the standards for mixture model. This mixture model, I say, mixed design. All right. And then we have very effective materials, and by those materials, this rapid method of mixed design, although many, but water is playing a vital role. So in this rapid method, basically we are using the boiled water, we are using the warm water, and many more things. So my basic objective, that civil engineering is basically the mother of all engineering branch, what I say. All right. And this has given foundation to all branch. This has given the foundation to all branch. And basically, as of now, as per the this economic downturn, how this branch will gain the glory, what are the research trend will change the dynamics. So my only objective as a director, in fact, institutional director, that we have to achieve the older glory of Department of Civil Engineering, which is the foundation of all engineering branch, basically. You see, in independent India, there are many canals, many highways, bridges. All these are tangible. Whatever the tangible we see, objects, which are serving the purpose of mankind by and large, are the construction of done by civil engineers. So nowadays this technology trend is very much up. So we have to see that how AI is useful for civil engineering branch, especially in concrete mixed design. Whatever the practices, whatever the analysis, we have to perform for the longevity and for testing as well. In fact, some automated testing devices should come, which wherein they have to test the strength and longevity as well, and they may reject. They may reject, as in India there are many things that the design is not very much appropriate, but people are accepting it, and there is no parametric check. So I think some kind of automated checks and balances should be there, which perhaps incorporated in our regulatory framework, and that can give the acceptance and resistance. Another point, in fact, related with the current surge of COVID-19 pandemic, this country and our state, Uttar Pradesh, and I'm not talking only about Uttar Pradesh, in fact, entire world, and especially India is very much affected. Our system is totally derailed, academic framework, thanks to the technology that we are at least trying to secure the interest of our students. So we all are very much concerned about the recent situation. However, in fact, let me share that Dr. Jan, in fact, family got affected, but by the God grace, now things are good, and Professor Jan is now come back on his main track of academia. And you see, this is today's seminar workshop is one of that his evidence of his activeness. Mr. Ankit Sharma is also supporting him. Shri Pipar Sanya Sahab, who is the senior faculty of civil engineering, and other faculty members also, Madam Nikita Jain, then Madam Nisa Sahel, and Mr. Amit is also supporting the department, and students are well connected with the faculty members. And I hope today, I'm not going to take much time, in fact. So today is the day of our resource person. So my sincere thanks to the Department of Civil Engineering organizing team, who have done this wonderful, who have created this wonderful platform for the students, and my sincere welcome to Shri O.P. Sharma Sahab for today's O.P. Sharma Sahab, who is the managing director of QTech, and my best wishes for today's session. Thank you. Namaskar.
Thank you, sir.
A very good morning to respected sir.
Yes, Nikita ma'am, you are audible.
Yes, sir. Am I audible? Yes, sir. Sir, a very good morning to respected Director, Faculty of Engineering and Computing Science, Professor R.K. Dwivedi, sir. Our chief guest and keynote speaker, Mr. O.P. Sharma, sir. Convener of the workshop, Head of Civil Engineering Department, Professor R.K. Jain, sir. Coordinator of the workshop, Mr. Ankit Sharma, sir. And all the available faculty members and dear students. In the behalf of Faculty of Engineering, Tirthankar Mahavir University, Moradabad, I, Nikita Garg, Assistant Professor, Civil Engineering Department, heartily welcome to our eminent keynote speaker, Mr. O.P. Sharma, sir, and all available dignitaries. I have a great opportunity to introduce our speaker, Mr. O.P. Sharma, sir. He is currently the Managing Director of QTech Readymax Concrete in Jaipur. He has 18 plus years of experience in the field of quality control, techno marketing, production, operations, construction, material management, research and development. Apart from that, he also works in various distinguished industries like JK Shri, JK Cement Limited in Delhi as a senior manager, Shri Cement Limited, Jaipur, and Ultratech Cement Limited, Jaipur. He works on various projects that covers major era of civil engineering. This is the short summary of our speaker profile. Now, I request to Mr. O.P. Sharma, sir, to grace us with their valuable words. Over to you, sir.
Thank you, ma'am.
Thank you, sir.
Good morning to all. And it's great pleasure and honor to me to be here. Warm thanks to Dwivedi sir, Jain sir, Mr. Ankit Sharma, and all faculty members and the students of Tirthankar University. Well, as Jain sir said, why concrete mix design is required? Basically, it's very dilemma that no one cares about the structure. Am I audible?
Yes, sir.
No one care about the structure. People just care about the imported tiles, branded marbles, paints, but they do not care about the structure. And the structure is the thing that cannot be changed. You can demolish, but you cannot change. Like आज ये स्लैब है, इसको मैं इधर शिफ्ट करके उधर ले जाने चाहता हूँ. It is not possible. So what is important? Only structure, like human body. Like skeleton is human body structure. Just like that, concrete structure is the skeleton for whole civil engineering structure. But nobody cares about the structure. They care about the beauty. And that can be changed, but structure cannot be changed. That's why concrete mix design is extremely important. And lot of things to be do by the government or regulating authorities to make the concrete mix design necessary for each and every project, not only large scale project, including housing project of individual house builder, small projects. So Ankit ji, can we start now?
Yes, sir. Yes, sir.
Not taking too much time. I'm sharing the screen. Okay. Can everyone see the screen?
Yes, sir.
Should I move
Yes.
further?
Yeah.
Yes, sir.
Ankit ji, do you want to add something or should I start?
Sir, you can start, sir, please.
Okay, again, welcome all. I am sharing the presentation on concrete mix design, and my approach will be on a simple practical way rather than a theoretical or mathematical tool way. I will do in a practical approach so that everybody can understand. And after that, we will have a Q&A session where we can share our views or we can have doubts clearing. So, what is our agenda today? The agenda is what is concrete? As Jain sir already told, what is concrete? Then, what is concrete mix design? And why is concrete mix design, that is CMD, why it is required? After that, we'll go with the raw materials that are to be used in concrete mix design, different stages of concrete, and after that, concrete mix design. So, coming to the point, what is concrete? Basically, whenever we ask what is concrete, usually everyone say it's a mixture of cement, water, aggregate. Aggregate may be fine. That is also called sand, and usually known as balu, reta, bajri, at different names at different places. Then coarse aggregate, 20 mm, 10 mm, 40 mm, and local names are gitti, rodi, and whatever. And after that, mineral admixture. It is not required at small sites, or usually it is added to the cement also at a cement plant, and then chemical admixture. But as Jensen said, a fixed proportion, a required proportion must be there. It is just like making a favorite recipe or a tea. If balance is not there, the recipe or tea or the concrete whichever we are making will not serve its purpose. And what is the purpose? For concrete purpose is workability. Workability means how it will work, how we can work with it, strength, durability. These are some requirements it should satisfy. So how it will satisfy? With the proportion, right proportion, required proportion. That we will see in further slides. So what is mix design? According to IS 456, it is the process of selecting suitable ingredients with certain proportion and to satisfy the requirements. What are the requirements? Minimum compressive strength, or in some case, if tensile strength is also required, workability, durability, but it should be economical as possible. Why economy is required? Being an engineer, it's our moral duty to make the optimization in civil engineering. Anyone can make the concrete. You just add the 10 bag of cement or 12 bag of the cement, concrete is there. If your required grade is M20 and 25, you are adding 10 or 12 bags of cement. It's not economic. It's not optimizing. When it is optimized, where if you are using minimum quantity of cement and getting the desired properties, then it is only optimized concrete mix design. And it is our moral duty, or we can say it is liability to us engineers to make it economical, but there should be no compromise on the desired properties. So what are the key points for concrete mix design? Objective: strength is required, workability is required, durability is required. optimized, as already I said, as economically as possible, and specialty. It is a topic of further discussion, specialty of concrete. It may be temperature controlled concrete, just like used in Saudi Arabia and certain mass concrete project. Flowability, like self-compacting concrete, widely used in projects these days. Porosity, color and pattern, like color concrete, stamp concrete, and density. Density means weight of concrete per cubic meter volume. It may be on lower side, lightweight concrete, cellular lightweight concrete. On higher side, high density concrete. These type of concretes are generally used in a cancer research institute where the radiation to be blocked. Okay. So again, what is concrete design? The proportioning carried out to achieve specified characteristics at specified days, at the age of 7 days, 14, 28, 56, as per the requirement of site, workability, and durability. Okay. Next, why a concrete mix design is required? See, at regular sites, generally nominal mix design is used by all the contractors or engineers, and who are the designer for them? The labor present at the site, they are the designer of the mix design. They will decide how much bag of cement is required, how much quantity of aggregate to be added, what quantity of water to be added, and it's not fixed. It's their just experience, or at you can say site requirement, that they are just mixing and placing, and once it is set, nobody cares. Okay, concreting has been done. My slab is ready, my column is ready, my beam is ready, all my structure is ready. So the point is why CMD is required. Why it is required? Because we have to choose the best proportion to make it economic and to serve the required properties of durability, strength, workability. So what are the requirements for it? What kind of cement we are using? We must know what kind of cement we are using. Specific gravity of aggregate, fine aggregate and coarse aggregate. Their specific gravity is to be known. Let me elaborate about the specific gravity. All engineers are here, but it is the most important term to be used in a concrete design, specific gravity. In a simple way, specific gravity is the weight of a material with respect to water. How much it is heavier to water, or how much it is lighter to water. And we can say, just like we always say, 1 liter of water is equal to 1 kg of water. It means the specific gravity of water is 1. Like that, we must know the specific gravity of cement, aggregate, and other material if we are using in concrete. Like OPC cement is having specific gravity of 3.15, means it is 3 times heavier than the water. Mostly aggregate, it may be fine or coarse aggregate, they are having a specific gravity of 2.5 to 2.7 or 7.5. It means they are 2.5 to 2.75 times heavier than the water. I will tell about specific gravity in further slides, why it is required or where it is to be used. Then we must have the grading of aggregate and site requirement. But all these things are not considered in nominal mix design. Why? Because a fixed proportion is given there, irrespective of the type of aggregate, irrespective of the type of cement, site requirement. You just add them in a fixed proportion, mix them, and pour them on the site. So as per the literatures available or with the past experience, up to M25 we have certain proportion. But if we go beyond M25 grade, we must need the proper mixed design. And what are these proportion? I will tell you. These are the proportion for M5 grade to M25. The most common grade these days is M20 and 25. Almost 90 to 95% of concrete is used is grade M25 these days. So what is the proportion? Cement, fly ash and coarse aggregate. 1:2 means one part of cement, one part of fine aggregate and two part of coarse aggregate. See, this proportion is on weight basis. Means you have to weight the material. Means if you are taking 50 kg bag of cement, you have to take the 50 kg of fine aggregate and 100 kg of coarse aggregate. But what is the practice at site? They do the volume batching. Means they take the one bucket of or one pharma of cement, one pharma of fine aggregate, sand, balu, reta, whatever, and two pharma of or two bucket of coarse aggregate. If we weight them, means what I want to say, we are doing volume batching. We are taking one bucket of cement, one bucket of fine aggregate, that is sand or red balu, and two bucket of coarse aggregate, 20 mm or 10 mm. And if we weigh them, we will get to know the proportion which must be 1:1:2 is now 1:1.5:4. Means your cement percentage had been reduced. You are adding more fine aggregate and coarse aggregate, and you are thinking about the strength and durability. No, it is not possible. Why? Proportion has been wrong. It is wrong. What is required and what has been done, both are very different. So, nominal mixed design generally carried out at the site, but they are not suitable to the requirement of the structure or as far as consideration to the strength and durability. Okay. Now, we will discuss about the material. Am I moving very fast, Ankit ji? Ankit ji, can you hear?
No,
No,
sir.
Am
No,
I
sir.
moving very fast?
Okay.
it's okay.
It's okay. Okay.
It's okay.
So, in our country, India, what are the types of cement available? We all know there are various types of cement, but mostly used cement are ordinary Portland cement and Portland Pozzolana cement, that is PPC and OPC. In OPC, we have two grades, 43 and 53. Earlier, 33 grade was also there, but now it has been obsolete or replaced by the PPC or PSC cement. So these four cements are mostly used, and other cements of rapid hardening, sulfate resisting, and white color cement. There are many types of cement. They are only 2% of the requirement of whole cement quantity. So, what should be the property of cement? It should be fresh and of obviously good brand. Means it should not be of any alteration. Lumps free, there should not be any lumps. Once the cement gets the moisture, lumps may be formed in the cement. And what are the requirement of site? Where you have to pour the concrete, what is the requirement of your structure, what is the location, whether it is on coastal area or in hilly area. On this basis, cement to be used. And proper storage is always required. It doesn't matter it's a small site or a big project, proper storage is always required. Next is water. Let me tell you one thing. We all are civil engineers and engineers. So after water, concrete is the most usable material in the world. Can you believe water is the most required material or necessity to whole world, and after that concrete is the most usable material in the world. So coming to the point, water. What should be the property of water? It should be in accordance with Indian Standard 456, Table 1, where certain properties of water are given: organic, inorganic, sulfate, chloride, suspended matter, and permissible limits are given there. If we test the water, it should be in the permissible limits. Or we can say the potable water, which is a drinkable water we are drinking, can be used in a concrete for both mixing, curing, both. The pH of water should not be less than 6. If it is less than 6, means water is on a acid medium. It will do harm to the concrete. And as we all know, the pH of neutral water is 7. So it is good if water is having pH between 6 and 8. And usually all potable waters are having the pH between 6 and 8. So potable water can be used. It should be free from organic impurities and seawater. Seawater cannot be used, or we must not use while making the concrete, or even while we are curing the concrete. Seawater we must not use. Why? Because it is having so much salts and impurities which will corrode the steel and ultimately make the reduction in the strength, will make the loss of durability of concrete, and final loss to the structure. Means the structure which have been made for the 50 to 60 year of service life may not give the desired lifespan. Okay. So coming to the fine aggregate and coarse aggregate. What are fine aggregate? The aggregate which are having size of 4.75 mm down are called fine aggregate. Or in a simple way, we can understand 5 mm down aggregates are fine aggregate. Okay. So what kind of fine aggregate should be used in a concrete? It should be of John 2 or John 3, that I will discuss on further slides. What is John or what is required. And again, it should be clean and free from any coatings of clay, silt, or other harmful material. It should be free from hygroscopic tendency. See, what is the meaning of hygroscopic? Means it must not have the tendency to repel the water. It must have the tendency to accept the water, not repel the water. It should be coarser, angular, hard, and sharp grain. Should not contain organic matter just like water. Fine aggregate also should not contain organic matter. Should be strong and durable, and should be well graded. What is well graded? Well graded means if we are making the sieve analysis of fine aggregate or coarse aggregate, there are certain sieve size and certain percentage is given in the IS code of IS code 383. So it must have all sieve size percentage. It should not be like there it is having the coarser material and not having the medium finer material, and again last having the finer material. It is just like any organization. Do you think any organization which is having only VPs, vice president and not having any officer, manager or labor class, can any organization of this type can be run? No. Or any organization which is having only labor class and not having any senior management? No. All are required in a fixed proportion, just like here. In aggregate, all sieve size must be there and with required proportion. That I will tell you later. Yes, these are the grading. So here you can see there are 7 sieve size: 10 mm, 4.75, 2.36. After that, 1.18, 600, 300, and 150. So we have to take the sample of fine aggregate, make the sieve analysis on given sieves, check for their percentage passing, and all sieve size must have the required material percentage. See, now here it is given John 1, John 2, John 3, and John 4. What is the meaning of John 1, John 2, John 3, John 4? It is not like that John 1 is from Kashmir or John 4 is from Kanyakumari. No, it is not like that. John 1 to John 4 is the particle size differentiation for fine aggregate. John 1 is the coarsest one, and John 4 is the finest one. So what we need mostly John 2 or John 3 for the concave mixed design, which is the most suitable John. And in my view, John 2 is the best proportion or John for making a concave mixed design with optimization. Here, I have marked 600 micron sieve with a red square. Why? Because this is the only sieve 600 micron, as you all see, where no overlapping is done for the percentage passing. Here in John 1, 600 micron, 15 to 34 is the limit. For John 2, 35 to 59 is the limit. John 3, 60 to 79, and John 4, 80 to 100. So it is only the sieve size where no overlapping is there. Okay. So only 600 micron sieve is which decide what is the John of the sand. Okay. Next. Next is coarse aggregate. As we discussed, material finer than 4.75 mm is fine aggregate. Then obviously material greater than 4.75 mm is coarse aggregate. Coarse aggregate may be of different types. It may be rounded, which usually come from the river beds, river sides, or angular aggregate, which usually come from the crushers. So what should be the property of coarse aggregate? It should be consist of natural stones. Obviously, all the coarse aggregate are natural stone, gravels, or in combination of different material. Again, it should be hard, strong, durable. Necessity of cleaning is always there. It should be dense and clear. No coating should be there. Again, vegetable or organic material should not be there. It should not contain flaky or elongated pieces. Obviously, flaky or elongated pieces will be there, but they must be in required limit. Flaky aggregate is which is having very thin dimension of, and elongated aggregates are which are having the long dimensions, which we can discuss later, no issue. And again, it should not have any material which is liable to attack steel reinforcement. Now, coming to the grading of coarse aggregate. So there are various sizes of coarse aggregate available: 63 mm, 40, 20, 16, 12.5, 10 mm. Mostly used coarse aggregate in concrete are 20 mm and 10 mm. So 20 mm down aggregates are widely used in concrete, and 40 mm size aggregates are generally used in PCC or lean concretes. And so what should be the grading? Again, for 20 mm, if we are taking the 20 mm aggregate, we have the C size of 40 mm, 20, 10 mm, and 4.75 mm. We have to do the CO analysis of the sample of force aggregate which we are going to use in concrete design, and again check for the percentage passing. It should come under the given limits, and what we'll do if it's not satisfying the given limits. If it is not satisfying the given limits, we can add further size of aggregate just like 10 mm and make their proportion to make a close grading which is given on the left side of 20 on the 10th column. Make their certain proportion, again check for the C size, and it should satisfy the given limits. So what is the proportion of 20 mm and 10 mm? It is generally used in a 60 and 40 ratio. Why it is? Because it was given in earlier IS 10262 as a guideline. But guideline को हम लोगों ने mandatory मान लिया, और generally अगर हम कहीं भी बात करेंगे, we usually talk at the site, and when you ask to them what is the proportion of 20 mm and 10 mm, everybody will say 60-40, 60-40. It doesn't matter. They do not care about the size of aggregate they are creating. But why? Because they heard from somewhere or someone that we should use the aggregate in 60-40 ratio. 20 mm should be of 60% and 10 mm should be of 10%. No, it is not like that. We have to check the aggregate, mix them, check their check for the CO analysis, and one more thing we have to do: take a density bucket beside the proportion like 60-40, then 55-45, 50-50. Mix both aggregate, fill the density bucket, and check the weight of aggregate. The proportion which is giving the highest weight is most likely to be suitable to the concrete mix design. Okay. Now, again, all in aggregate grading, which is very important term in concrete mix design. So what we are using cement, water, then we are using fine aggregate, which is sand, and coarse aggregate of 20 mm, 10 mm, or 40 mm water. So the proportion of sand and coarse aggregate should be in a such way that it gives you denser packing, or I should say dense packing. So for that, the limits are given in the IS 383, page 7, table 10. Take the proportion of sand 20 mm, 10 mm, mix them, and go with the CO analysis. So limits are given there that for 20 mm nominal size, 40 mm sieve size, all the material should pass from the 40 mm, means the material should be 40 mm down. So it should pass 100% from the 40 mm. Then on 20 mm sieve, the proportion should be 95 to 100. On 4.75 mm sieve, 30 to 50, 600 micron, 10 to 35%, and 150 micron, 0 to 6%. My suggestion is to keep the proportion or the reading within the given limits. Means for 4.75 mm, if the proportion is coming to percentage is coming to 40 to let's say 38 to 45%, it is very good. And for 600 micron, if it is coming to 15 to 20%, very good. It will give you dense packing in the concrete. That will ultimately save your cement, will give you a good workability, and obviously strength will be higher. Now, it is the most important term in concrete mix design, which that is SHD condition, saturated surface dry. Let me explain what is SHD condition. As we know that there is term in concrete mix design, water cement ratio, means how much quantity of water we are using and how much quantity of cement we are using. The water weight of water divided by the cement, that is water cement ratio, which gives the quantity of water required in the concrete mixture. See, why we are adding the water? Because cement always need water. Without water, there is no importance or there is no working of cement. Cement will not serve any purpose if we are not adding water to it. So what is our requirement? Our requirement is to make the cement paste. We want to add the water to the cement so that it make the paste or the chemical reaction of hydration may go on, and some workability. Again explaining, then when we are adding water to the cement, it will make the paste, hydration of cement will start, and in concrete mix, water is also required for the workability. So why we are adding water? We are adding water for the hydration of cement and for workability of water. Let's say our water cement ratio is 0.5, means we are using 50 kg of cement and we are adding 25 kg of water. So water cement ratio is 0.5. We are adding water for the hydration reaction of cement and for the workability of mix. And suppose our aggregate is totally dry. We are adding the 25 kg of water. But what will happen? Out of 25, 2, 3, 4 kg or 5 kg water will be absorbed by the fine aggregate and the coarse aggregate. We are adding 25 kg for the reaction and workability, and what we are getting less than 25 due to the water absorption or water absorbed by the aggregates added in the concrete. And in a vice versa, if we are as like a rain is going out these days, we are using the aggregate which is moist or it was in the outside and the rain was going on. We are adding, and that aggregate is having water, say 5% of their weight or 10% of their weight, and we add that material to the concrete. What will happen? We have given only 25 kg of the water, and the factory water will be more than 30 or 35 kg in the concrete, and then we will surprised what is happening. What is happening to the mix? Mix is so flowable, or it is having bleeding or segregation, which we will discuss on a further slide. So, what is the surface saturated surface dry condition? It means in a simple way, if I tell you, जो भी एग्रीगेट हम यूज कर रहे हैं, फाइन एग्रीगेट, कोर्स एग्रीगेट, जो भी हम यूज कर रहे हैं, वो उस कंडीशन में होना चाहिए कि ना वो पानी लेगा और ना पानी देगा. गेटिंग माई पॉइंट? मैंने जो भी 20 mm हमने जो भी सैंड यूज किया है, 20 mm और 10 mm वाटर वी आर यूजिंग, ना उसको वाटर लेना है ना मिक्स के अंदर अपने तरफ से वाटर देना है, सो दैट हमारा वाटर सीमेंट रेशियो मेंटेन रहे, हमारा वर्केबिलिटी प्रॉपर रहे. अगर इस पोजीशन में हम एग्रीगेट को ले आते हैं, मीन्स कि उसके जो पोर्स हैं, लाइक द थर्ड शेप, पोर्स जो भी हैं उसके रिक्वायरमेंट के हिसाब से उनमें वाटर फिल है, बट सरफेस ड्राई है. अब अगर हम उसमें वाटर ऐड करेंगे, उसको वाटर देंगे एग्रीगेट को, इट विल नॉट टेक एनी वाटर, और अगर हम उससे वाटर आउट करेंगे, इट विल नॉट गिव आउट द वाटर. मीन्स aggregate should be in a position or a condition that it is not taking the water which is added for the cement reaction, or not giving the water to the concrete mix. That condition is SHD condition. Again, it is a hypothetical condition. In a lab for a small batch size, in a lab trial, we can make the aggregate as in SHD condition. But when it comes to the commercial production, where tonnage of the aggregate or cement to be used, it is not possible to make the aggregate in SHD condition. Okay. Next, chemical admixture. Chemical admixtures are these days widely used in construction field. I think all of you heard about the Dr. Fix-It. That is done by Mr. Amitabh Bachchan. So that Dr. Fix-It also an admixture. So there are various types of admixture. This is accelerating admixture, which is used for the fast setting of concrete. Retarding admixture to delay the setting of concrete. Water reducing admixture to reduce the water demand of concrete. Air entraining admixture to increase the workability of the concrete or somewhat to make the lightweight concrete or cellular lightweight concrete. Mostly used admixture is super plasticizing admixture, which is having the two properties. It is having the retarding property, means it delay the setting or make the liveliness of concrete for longer time and reduce the water demand of the concrete. So what should be the properties of aggregate? So certain properties are given in Indian Standard 9103, which we will not discuss here. The most important property is pH should not be less than, just like water. The admixture should not have the pH less than 6. And if we are using the chemical admixture in concrete mix design, it should give around 20 or 25 or 30% water reduction. If we are taking it just for 5% of water reduction or 7% of water reduction, then it is of no use. It should not have any chloride content, or if it is having, it should be well within limits. And while we are when we are using the super plasticizing admixture, the strength of concrete should increase with respect to the control mix, which is to be prepared without the admixture. Okay. So what are the different stages of concrete? First one is batching of concrete, which we have discussed, the nominal mixed design, nominal batching, or concrete mixed design, the weights given according to the concrete mixed design. After that, mixing of ingredients, mixing of cement, water, fine aggregate, coarse aggregate, or chemical admixture, and if we are using further other materials like polypropylene fiber or steel fiber, according to the requirement. Placing of concrete, where it has to be placed, like for column, beam, slab, or foundation. Compaction of concrete. The compaction of concrete is always required. Without compaction, concrete may lose the, let's say, 20 to 25% of strength. Then finishing of concrete. After that, once we have finished the concrete, what will come next? Hardening stage. Hardening stage means now we have to cure the concrete for certain periods, let's say 10 days, 14 days, or more period for 21 days as per the requirement. After that, once it is hardened, we have done the sufficient curing. What we'll do? We'll remove the formwork. Why we'll remove the formwork? Now concrete is okay. It is ready to take its own weight or other weight which are coming to it. And after that, long-term performance means concrete is in service. It may be for 10 years, 15 years, 50 years, whatever, as per the lifespan required with the structure. So, coming to the concrete mix design, what is the scope? Or we can say what is the purpose? The purpose of concrete mix design is, as already I said, we have to choose the best proportion, but in a economical, optimizing way. Not it should not be like that. Let's say 10 bags of cement and 12 bags of cement we are adding, and though they are not required. So when it comes to the concrete, again we are discussing what are the characteristics required: strength at certain age, workability, and durability. Now I am explaining workability. What is workability of concrete? The workability of concrete means, in a simple definition, by virtue of which we can do the work with the concrete. No, it's not like that. Workability of concrete means if we are making a concrete, हमको क्या करने का उसको हमको उसको पहले मिक्स करना है, देन वी हैव टू ट्रांसपोर्ट, हमें उसको ले जाना है, फिर हमको प्लेस करना है, देन हमें उसको कॉम्पैक्ट करना है और फिनिश करना है. तो ट्रांसपोर्टेशन से लेकर फिनिशिंग तक का जो भी वर्क है, अगर वो इजीली हम कर पा रहे हैं उस कंक्रीट के साथ, वी कैन से इट्स अ वर्केबल कंक्रीट और a concrete with a good workability, or the concrete which is satisfying the site requirement of workability. Now, what are the concrete grades available or generally used at the site? There are two types of concrete grade: ordinary, standard, and high strength concrete. Three types basically. Let me show here. Ordinary concrete is M10 to M20, or below M20 basically it's a PCC, plain cement concrete, where steel is not used. M20 to M50 or M55 is standard concrete, which is generally used on various sites. And M55, M60 above, these are high strength concrete, which are generally used in projects of where much load to be come, like metros or high-rise apartments of Mumbai or in Delhi, where the stories are more than 50, 60 or 80 floors. There, such high grades concrete to be used. Now, what is M? M refers to the mix. Sometimes when you are at the site, even engineers say M for masala. No. Friends, please always remember M refers to the mix. It's not masala. It's not mortar. Masala is mortar, which is a mix of sand and cement, where coarse aggregate not used. M stands for the mix only. Okay. And after that 10, 15, 20, 35, 40, 45, it is the strength of concrete at 28 days, when we make the 150 mm cube of the concrete and we check them in the compression testing machine. So if we discuss, let's say we are discussing M25 and we are making the cubes of M25 and we are checking them, we are testing them, the strength should come more than 25 Newton per mm square or 25 MPa, megapascal. Then it will be called M25 grade. Like that in M30, if we check the cube, strength should come more than 30 Newton mm square or 30 megapascal. Next, here we are discussing IS 10262, and IS 10262 also said that we must take concern of the guidelines given in IS 456 or the requirements given in 456, which we will see in further slides, which is most important for the concrete mix design. So here are some references which will need to be used while doing the concrete mix design. IS 383, which refers to the specification for coarse and fine aggregate. IS 456. We all engineers know about the 456. It's just like a Bible to us. IS 2386, IS 3812, which is for the pulverized fuel as specification. IS 269, ordinary Portland cement specification. Now, after 2015, the specification for all the cements have been included in only one code of IS 269. Earlier, there were different codes for the OPC cement. IS 1489, which is for PPC, Portland Pozzolana cement. IS 455, Portland slag cement. And IS 9103, which refers to the specification for concrete admixture. So now we are coming to the practical work of a mixed gen. How we will do the mixed gen? First of all, what we need, we must know what we are going to do. So what we need the concrete grade. Obviously, we are going to do the concrete mixed gen, so then we must know the grade, which grade is required. अगर हमको पता ही नहीं कि हमको बनाना क्या है तो हम करेंगे क्या. So we must know the grade of concrete, as we earlier discussed. So we must know which grade we are going to produce. M20, 25, 30, 45, 50, which one? So we must know the concrete grade. Then what kind of cement we are using? We are using OPC cement or PPC cement or PSC cement. In OPC, we are using a 43 grade or 53 grade. We must know the type of cement. Then we must know minimum cement content for a particular grade. What is the quantity of cement below which we cannot go? We will discuss here. Maximum water cement ratio. We must know what should be the ratio of water to the cement, and it is maximum. See here, cement content is minimum, means cement quantity is minimum, below which we cannot go. And the water cement ratio is maximum, means it is max water cement ratio. Beyond it, we cannot go. So our water cement ratio should be well within limits, and our cement content should be more than the required minimum cement content. And how we will get it? From where we will get it? We will get it from IS 456 2000 table number 5. It is given on page number 20 here. You can see here on the left side, it is for plain concrete M15 to M25, and on the right side is for reinforced concrete M20 to M40. Certain exposure conditions are given on left side: mild, moderate, severe, very severe, extreme. See, these are the climatic condition or the condition or the severity which the structure has to be faced while serving its span life. So according to that, the grade of concrete is selected. See, in a coastal area, we cannot use concrete which is used in a mild area. Means here in UP or in Rajasthan, we are having such places of mild and moderate climatic conditions. But when we discuss about the Chennai and Goa or Mumbai, where mostly the coastal areas, they are having extreme impact of saline water. So the grade of concrete like M20 if we are using here, same grade of concrete we cannot use at those places of coastal area or having the severe condition. I will tell you about the climate exposure condition. So what should be the minimum cement content? If we are making the M20 of RCC concrete, it should not be less than 300 kg. Means 6 bags of cement we must use, not less than that. So we can use 6.5 bag, we can use 7 bag, but we cannot use 5.5 bag of cement. Again, the term is given here minimum cement content. अधिकतर काफी लोग से थोड़ा सा कंफ्यूजन में रहते हैं. व्हाट इज सीमेंट कंटेंट? बेसिकली सीमेंट कंटेंट इज cement plus any additional supplementary material added to it. Like we are using say ordinary Portland cement, OPC cement, and if we are adding fly ash to it, then the minimum cement content should not be less than 300. If we are not adding any fly ash or slag to the OPC cement, again cement content should not be less than 300 for M20 or M25 kg. If we are using supplementary cementitious material, again limit is 300. If we are not using the supplementary cementitious material, limit is 300. So we'll replace the cement content with the term binder. We'll use the term binder, which is OPC cement plus fly ash or slag. Nowadays, PPG cement, it is already having the percentage of fly ash of around 32 to 33%, which will already mix in the cement plant. So when we are using the PPG cement in concrete design or at site, we cannot add fly ash or silica or other supplementary cementitious material to it. So if we talk about the grade of concrete, let's say 25. So what should be the minimum cement content? 300 kg. 300 kg should be the minimum cement content. Means 6 bags of cement must be used there. And what is the maximum free water cement ratio? 0.5. Means if we are using 300 kg of cement, you cannot add more than 150 kg of water. Okay. If you are using 350 of kg of cement, you cannot add more than 175 kg of water in a M25 grade of concrete. Okay. Now coming to the exposure condition. So these are the exposure condition: mild, starting with the mild, moderate, severe, very severe, and extreme. In India, the northern area of just like Rajasthan, Haryana, Punjab, we are having mild and moderate exposure condition. And when we go to the south side, where conditions are from severe to extreme. And according to that, we have to select the grade of the concrete. So we discuss about the moderate. What it say? Concrete surface sheltered from severe rain. Means rain is there, but not of severity. Concrete exposed to condensation. Concrete continuously underwater. Concrete in contact or in buried with non-aggressive soil or groundwater. Or concrete is protected from the saturated salt air. So when these are the exposure condition or climatic condition, we will say the area is in moderate exposure. So minimum grade of concrete should be M25. We can use M30, 35, but we cannot use M20. Like that, if we go with the severe condition, the minimum grade of concrete is M30. So the area which is having the severe exposure condition, when we design the concrete, our minimum grade of concrete should be or must be M30, not below that. Okay. Now, maximum nominal size of the aggregate. Now, maximum nominal size of the aggregate, it means the maximum size aggregate. हम किस size का aggregate, जो बड़े से बड़ा जो aggregate हम use कर रहे हैं, उसका size क्या है? So as we discussed sand and coarse aggregate. Coarse aggregate we are having 20 mm and 10 mm. So here if we are using 20 mm, our maximum nominal size will be 20 mm. Okay. So according to that, in IS 456, what is given? If we are using 20 mm of aggregate of maximum size, what should be the water content? Adjustment to water content 0. Means what water is coming out to the concrete mixture, and maybe 170 liters of water or 180. We do not need any addition or subtraction from the water. If you are using only 10 mm aggregate, or the maximum size of aggregate is 10 mm, half to the 20 mm, The aggregate size is just half to the 20 mm. What will happen? We have to add additional 40 kg of water per cubic meter of concrete. And we are using the maximum aggregate size 40 mm. We can reduce the 30 kg of water. And this addition and subtraction is with reference to the 20 mm, where the addition or subtraction is not there. No adjustment is required. And why it is required? See, let's say we are using 700 kg of the or 1000 kg of the aggregate in concrete mixture. I am making 3 concrete mixture where I am using 100 kg of coarse aggregate. In A mix, first mix, I am using 10 mm only. In second mix, I am using 20 mm only. In third mix, I am using 40 mm. What will happen? I have taken the weight same, 1000 kg in each mix. Okay. But I have to add additional 40 kg in 10 mm size concrete mix. I have to reduce 30 kg in 40 mm size mix. Why? It is due to the surface area of the aggregate. See, weight is same, 1000 kg. We are taking the weight of a coarse aggregate 1000 kg in all mixes. But when we are using the 10 mm aggregate, in same weight, we will get more surface area because we are using the finer aggregate. Like that, if we are using the 40 mm aggregate, in same weight, we will get less surface area. So we need less water. Okay. So coming to the next slide. Sorry. So next requirement is workability. So in IS 456 page 17, certain workability requirements are given according to the structure. It is given very low, low, medium, high, and very high. Or if we go with the slump value, so 25 to 75, 50 to 100, 75 to 100, 100 to 150. And workability is to be selected according to the structure. Like if you are doing the mass concrete or lightly reinforced slabs, we can have the workability of 25 to 75. If we are doing work concreting in a heavily reinforced structure, the requirement of workability or slump may be more than 100 mm. Let me tell you about the slump. Slump is tested with the slump cone, where we fill the sample of concrete in 4 layers, and we tamp each layer 25 times. Then we gradually lift the cone, and we check for the fall of the concrete, how much it has fall. It is 50 mm or 70 mm or 100 mm. The more the fall, we say higher the workability of the concrete. Lesser the fall, we say less the workability of the concrete. Now, we have discussed about the minimum cement content. Now, we must know about the maximum cement content. So, in IS 456, it is given we cannot use more than 450 kg of cement per cubic meter of concrete unless it is approved by the in charge of the site or the designated authority. But it is only for the in case of OPG cement. If we are using only OPG cement, we should not add more than 450 kg of cement in a cubic meter of concrete. If we are using PPC or PSC cement, or we are adding fly ash or slag to the OPG cement, then we go beyond the 450 kg limit. What will happen if we use a higher content of cement? If we use the higher content of cement, it will give high heat in the mix, due to which drying shrinkage means earlier thermal cracks will happen in the concrete, or in a later stage cracks may also formed in the concrete, which will ultimately harm the durability of the concrete. Again, what kind of aggregate we are using, we must know, and see analysis of the aggregate we must know, as we discussed earlier. Maximum temperature of the concrete in general sites or regular sites, generally it is not required, because at the maximum place we are having the temperature of say 10 degree to 40 or 45 degree in summer, or let's say 10 degree in winter. So the temperature of a range of 10 degree to 30 or 32 or even 35 degree is suitable for the placing of concrete. Method of transporting, how we are going to transport the concrete, and for how long period we are going to transport. Let's say we are producing the concrete at a site, and we are supplying the concrete to the various site of 20 kg distance, 20 kilometer distance, or 30 kilometer distance, or 50 kilometer distance. According to that, we have to make the mixed design. Early age strength requirement. If there is any early age strength requirement, like when it's come to the post tensioning of the slab, where strength is required in 10 days or 14 days, and after achieving the certain strength, the post tensioning of the structure is done. Next, whether we are going to use admixture, as we discussed, super plasticizer or not. If we are using the admixture, then the mix will be different to the mix where we are not using the admixture. So, how we will decide what will be the strength of the concrete? So here I am taking the example of let's say M25 grade. So there are certain terms. First is mean compressive strength, or characteristic compressive strength of the concrete, which is FCK bar, and equals to the FCK plus 1.65s, or FCK bar equals to FCK plus X, whichever is higher. So what is this? Actually, see, I want to make the concrete design for grade M25. Okay, and मैं डायरेक्ट तो साइट पे जाके मिक्स करना स्टार्ट नहीं करूंगा. पहले लैब में हम उसका एक प्रोटोटाइप बनाएंगे, एक सैंपल बनाएंगे, नंबर ऑफ सैंपल्स बनाएंगे, उनको हम लैब में टेस्ट करेंगे. 25 से ऊपर का स्ट्रेंथ हमें मिल रहा है कि नहीं मिल रहा. अगर मिल रहा है देन इट इज ओके. नहीं मिल रहा है तो वी विल इंक्रीज द सीमेंट और वी विल मेक सम करेक्शंस इन द मिक्स डिजाइन. अगर हमारा को मिल रहा है, हमारा M25 उससे ऊपर स्ट्रेंथ मिल रहा है, तब हम उसको साइड पे यूज कर सकते हैं. बट लेट्स से मुझे 25 और 26 मिल रहा है, 26 मेरे को मिल रहा है, 26 आई एम गेटिंग इन द लैब. When it comes to the site, I will definitely not get more than 20 or 22 at site. Why? Because there are certain limitations at the site. In lab, we have all conditions according to the codal provision or Indian standard requirement, where we are doing the querying of concrete sample at 27 degree. We are changing the water of the tank. But at site, these things are not possible. So what we have to do? We have to take some precaution, or we have to add some extra Newton per mm square or megapascal to the desired grade. Let's say M25. So we must increase the 25 to the certain level. And how we will increase? We will increase from this formula. FCK bar equals to FCK plus 1.65s. So FCK is our 25 if we are talking about the M25 plus 1.65. It's a factor which is corresponding to the 1 in 20 or 5%. What is this? Actually, 1.65 is a factor which is considered against the 5% failure. Means if we are testing or checking the 100 samples for the M25 grade, as we are designing here, not more than 5% results should fall below the 25. Getting my point? If we are testing 100 samples, उसमें से 5 से ज्यादा हमारे सैंपल फेल नहीं होने चाहिए. उसके अकॉर्डिंग हमने ये 1.65 का फैक्टर लिया. और नेक्स्ट है FCK बार इक्वल टू FCK plus X. X is the factor based on concrete grade. I will show you the value of S and X here. This is the concept of 1.65. Here you can see minus sigma to plus sigma. 34.13 is on the lower side, 34.13 on the higher side. Means our more than 90% result will fall in this range, and according to that, the factor is minus 1.645 to plus 1.645. From here, we have selected the 1.65 as a correction factor. See, now what is the value of S? Value of S is the assumed standard deviation, which is given in the IS 456 for our reference. If we are designing the concrete of M15 and below, the value of standard deviation S will be 3.5. If we are making concrete design of 20 or 25, the value of S should be 4. And if we are making concrete of more than 30 M30 grade, the value of S should be 5. See, ये जो वैल्यूज हैं ये उन कंडीशंस को कंसीडर करते हुए रखा गया है कि हम प्रॉपर स्टोरेज करेंगे सीमेंट का, वेट बैचिंग करेंगे, हमारा जो वाटर का एडिशन रहेगा वो कंट्रोल्ड रहेगा, मटेरियल को हम पूरा प्रॉपर्ली चेक करेंगे, अगर कुछ मटेरियल में प्रॉब्लम है तो हम उसको रिजेक्ट करेंगे, उसको यूज नहीं करेंगे, प्रॉपर ग्रेडिंग करेंगे, मॉइस्चर कंटेंट चेक करेंगे. ये सब इतना हम कंट्रोल करेंगे तब हम ये वैल्यू यूज कर सकते हैं 3.5, 4.5. अगर हमारा इनसे डिफरेंशिएशन है, हम ये सब नहीं कर पाते हैं, we are not able to do all this exercise, then we have to increase the value of S. Like for M25, the value is given 4. We can use 4.5, 5, 5.5, 6. We can increase. But if we are increasing the standard deviation, means we are going for the higher target strength. The higher target strength will result in more consumption of cement. Here in table, the value of X is given. For M10 and M15, it is 5. For M20, 25, 5.5. And for M30 to 60, it is 6.5. And for M60 and above, it is 8. So what will be the target strength for let's say M25 grade? FCK is 25 plus 1.65 into 4, the standard deviation. The value is 31.6. And from the next formula, FCK plus X means 25 plus the value of X is for 25 is 5.5. That is 30.5. So which target strength we'll choose? We'll choose 31.6. Because whichever is higher, we have to take that as a target strength. Here we can see from where the 1.65 correction factor is taken here. Accepted proportion of low results 1 in 20 means in a 20 sample, one sample may be fail, or we can allow the failure of one sample after 20 sample. Then we use factor of 1.65. If we allow only one sample out of 15, then we'll use 1.5. If we allow only 1 in 40 sample, then we'll use 1.86. Okay. Now, first ingredient which we have to find out in concrete mixant is water. From where we'll get the water? We'll get it from the IS 456 table, or if we have the past experience from there we can choose. But we must consider how much water to be used in concrete, and the water content in concrete is influenced by what kind of aggregate we are using, means what is the nominal size of aggregate, as we earlier discussed, aggregate shape, what is the shape of aggregate, it is round, irregular, angular, aggregate texture, whether it is a smooth type aggregate or it is a rough aggregate, workability, whether we need high workability or we need lower workability, cement type, what kind of cement we are using OPC or PPC or PSC cement, supplementary cementous material, whether we are using fly ash in mix or not, we are adding GGBS, granulated glass slag, or other, we are using chemical admixture or not, and environmental condition. So, according to IS 10262, if we are very new to the concrete mixant and we don't have any past data, we can take the help from this graph. We have to just mention what strength of concrete we need in 28 days and what kind of cement we are using. So curve 1 is for cement having a compressive strength of 28 days less than 43, which are generally PSC or PPC cement. Second curve is for the cement having strength 43 to 53. And third one is for the cement having strength more than 53. That is OPC 53 grade cement. So we decide to make a concrete of M25, and we decide let's say we have the strength of 31.6 target strength in 28 days, and we are using the OPC 43 cement. Then we can use the curve 2. So corresponding to 31.6, if we see the here 0.5 and 30, if you see their intersection, the water cement ratio is 0.5. Okay, but my suggestion is not to go with this graph. Instead of this, we should go with the table given in IS 456. This one. Here, for M25 grade, maximum free water cement ratio is given 0.5. So we can take the water cement ratio as 0.48, 0.47, 0.49, 0.485 according to our requirement. They no need to go with the graph. And this water cement ratio is irrespective of the type of cement. So it doesn't matter you are using the OPC cement or PPC cement, or you are adding the fly ash to the OPC cement. Doesn't matter. We can choose our water from here. Okay. So After deciding the water cement ratio, we have decided the water cement ratio 0.48 for M25 grade. What comes next? We have to find out the quantity of water, how much kg or how much liter of water is required. So, in a table, for the nominal maximum size of aggregate, maximum water content per cubic meter is given for our reference. If we are using 20 mm aggregate, nominal maximum size, we can use the water 186 kg of water in a cubic meter of concrete. आई एम सॉरी, मैं आपको क्यूबिक मीटर का एक्चुअली इलाबरेट नहीं किया. एक्चुअली व्हाट हैपन, तो कंक्रीट जब हम प्रोड्यूस करते हैं और सप्लाई करते हैं या यूज करते हैं साइट पे, तो उसका जो यूनिट है दैट इज क्यूबिक मीटर. वी डू नॉट टॉक अबाउट द वेट ऑफ कंक्रीट, वी टॉक अबाउट द cubic meter of concrete. Means we talk in the volume, how much cubic meter of concrete is required. So if we go with the 1 cubic meter means if we have a certain tank of 1 meter by 1 meter by 1 meter, means 1 meter length, 1 meter breadth and 1 meter height, and we fill it with the concrete. And after that we wait for the weight of concrete. What weight of the concrete is coming? Let's say 2300 or 2350 or 2400. That is the weight of concrete in a cubic meter. Okay? Or simply 1 cubic meter is equivalent to 1000 liter. See, so here the water content is given for 25 to 50 mm slump. Means for 20 mm maximum size aggregate, if we use 186 of water, we may get 25 to 50 mm slump. And if our requirement is more than 50, then what we have to do? For every 25 mm, we have to increase the water by 3%. Again, this water content is given for angular aggregate. If aggregate size is subangular, then we can reduce 10 kg of water. If gravel used, we can use decrease the water by 20 kg. If we are using rounded aggregate of river size river bed, we can reduce by 25 kg. Let me show you the shape of force aggregate. This first one is angular, second subangular, and so on, and last one is well rounded. Now, according to their shape, if we go with the well rounded and smooth aggregate, what will happen? We'll get good percolability. But when it comes to the adhesion of cement to the aggregate or bonding of cement with the aggregate, it will be very bad. Means we will get the less strength. If we go with the angular aggregate, concrete handling will be tough, but the bonding of cement paste to the aggregate will be very high or good. Means it will give us a good strength or higher strength. Now, we have find out the water. We have find out the water content. So, next is the quantity of cement. So, if let's say we have find out the water for 20 mm, 186 kg, and we are taking the water cement ratio as let's suppose 0.5. So, what we have to do? We have to divide the 186 with the water cement ratio of 0.5. It will come around 390 kg or something, 372. So that will be our cement content. Again, check it with the minimum cement content requirement. Just like for M25 grade, it is given minimum 300 kg. So it should not be less than. And again, check it for the maximum cement. That is 450 kg. It should not be more than 450 kg for OPG cement. Now we have find out the water, we have find out the cement, rest is aggregate. See, why aggregate is required? Basically, the aggregate जो है, it fills around 70 to 80% of volume in a concrete. If we do not use aggregate in concrete, it will be quite uneconomical, or there may be there will be sometimes some durability issues if we use high cement content in the concrete mix. So we can say the aggregate work as a volume filler in a concrete mix. So what we have to do, how we can find out the quantity of aggregate. So in IS 10262 table 3 is given, where again, according to sand zone, zone 1, zone 2, zone 3 and zone 4, and for the maximum nominal size, the percentage of coarse aggregate is given there. So we are having sand of zone 2, and we are using the 20 mm maximum nominal size aggregate, means our aggregate maximum size is 20 mm, not more than that. So how much percentage of coarse aggregate should be in concrete? 62%. That is 0.62, 62%. Means 62% will use coarse aggregate, that is more than 4.75 mm size, up to 20 mm. And 38% will use the fine aggregate, that is sand, balu, reta, bajri. Again, here if you see, the volumes are based on aggregate in saturated surface dry condition. Means what we have discussed already, the condition of aggregate should be in a SHD condition, and it is not possible to make the oil aggregate in SHD condition for bulk production. So what we'll do, we'll make some corrections to make the aggregate in SHD condition, and we'll see in the practice sheet that. So the proportion here given are for water cement ratio of 0.5. It is standard. If we are taking the water cement ratio of 0.5, we are taking maximum nominal aggregate size 20 mm, and we are using the zone 2 sand. Our coarse aggregate percentage is 62, means our sand percentage is 38. If you are using zone 3 sand, then coarse aggregate percentage is 64, sand percentage is 36. Why coarse aggregate percentage is increasing? Because zone 2 से फाइनर है zone 3, zone 3 से फाइनर है zone 4. अगर फाइन एग्रीगेट जो है हमारा सैंड है, अगर वो फाइनर साइड में जा रहा है तो हमें सैंड का परसेंटेज कम करना होगा और कोर्स एग्रीगेट का बढ़ाना होगा. अगर हमारा सैंड कोर्सर्स का है तो हमें सैंड परसेंटेज इंक्रीज करना होगा और कोर्स एग्रीगेट का परसेंटेज डिक्रीज करना होगा. जस्ट लाइक गिवन इन जोन 1, हियर फॉर 20 mm aggregate size, the percentage of coarse aggregate 60 and sand percentage is 40. Okay. Next, for every change in water cement ratio of plus minus 0.05, we have to reduce or increase the coarse aggregate. How? Let's say our water cement ratio is 0.45, and these values are given with reference to 0.5. So water cement is reduced by 0.05, means the quantity of water is lesser in concrete. Then what we have to do? We have to increase the coarse aggregate and we have to reduce the fine aggregate. Means if we are reducing the water cement ratio, we have to increase the coarse aggregate. If you are increasing the water cement ratio, you have to reduce the coarse aggregate and increase the finer aggregate. Next, how we will find out the fine aggregate? We will find out the fine aggregate by formula 1000. 1000 is the liter, that means 1 cubic meter. 1000 will divide the mass of cement, and in 1000 we will subtract the mass of cement divided by the specific cement, which will give us the liter of cement and water content. Don't worry, we'll do the exercise on this. So from there you will get to know more, or we will get more understanding on this. By doing this, we will get the volume of aggregate. Okay. If we have the volume of aggregate, here we have the proportion of aggregate, that is 62:38 or 64:36. Let's say 700 liter is the volume of aggregate, 700 liter, not kg, in the concrete. After that 700 liter, let's say 40% is the part of fine aggregate, sand, and remaining 60% is the part of the coarse aggregate. So what we'll do, we will multiply the total volume of aggregate with the percentage of coarse aggregate and the specific gravity of the coarse aggregate. And just like that, we will multiply the total volume with the percentage of fine aggregate and with the specific gravity of the fine aggregate. After that, we'll get the weight of coarse aggregate and fine aggregate. We can divide coarse aggregate into 20 mm and 10 mm, and which is good practice. Instead of using single size aggregate, use 20 mm and 10 mm size aggregate, which will give more dense packing and good workability and economy as far as concerned with the cement quantity. So I thanks to the Tirthankar Mahavir University, the Professor Dwivedi, Professor Jain, Mr. Ankit, all organizing members and aspiring engineers. And further to this, now we will have one workbook of concrete mix trial in Excel format, which I will share to all. From this exercise, we'll get more knowledge about the concrete mix design. So actually, generally क्या होता है कि theoretical तो हो जाता है, but when it comes to the practical approach or practical calculation, काफी लोगों को confusion रहता है, problem रहता है. So on Excel sheet, we'll do the exercise. So here we are doing one exercise of grade M25. From there you will get more knowledge or more explanation what is how we calculate the proportion of aggregate or cement and water. So what is first needed to us, grade designation. As we discuss, we must know for which grade we are going to do the concrete design. Here I am taking M25. Again, next type of cement, I am taking OPC cement. Then my maximum nominal size of aggregate is 20 mm. According to IS 456, minimum cement content is 300. According to IS 456, table 5, maximum water cement ratio is 0.5. Work quality, here I am doing trial for the 100 mm. Okay. Next, exposure condition, moderate. If we talk about the Moradabad or Jaipur, we have the moderate conditions. So we are designing for the moderate. And according to moderate condition, minimum grade of concrete should be AM25. We can design for higher grade, AM30, 35, 40. Here we are taking the example of M25. How will you place the concrete? We'll place it on a pump. With a machine, we will place it to the sides. Or we can directly dump it from the mixer. Okay. Next, degree of supervision. It is good. Means we will have the control on all incoming raw materials, water content, proper storage of cement, periodical testing of the all aggregates and material. What kind of aggregate we'll use? We'll use a crushed angular aggregate. We are not using here a rounded aggregate. So maximum cement content, we all know 450 kg per m cube given in IS 456. Super plasticizer, yes, yes, we are going to use super plasticizer. Type of mineral admixture, here given fly ash, I am not going to use it. I am making it a none. I am not going to use fly ash. Then, next come to our data. What kind of cement we are having? OPC, OPC 43. Specific gravity of cement, usually all OPC cement are having specific gravity of 3.14 or 3.15. Chemical admixture, yes, super plasticizer we are using. Specific gravity of fly ash, no, we are not using any mineral admixture or fly ash. Then specific gravity of coarse aggregate, here I am taking the value of 2.62. See, specific gravity and water absorption are most needed terms in the concrete mix design. And according to IS 2386, we can find out the specific gravity and water absorption. Specific gravity of a fine aggregate, I am taking 2.65. Now water absorption of coarse aggregate, I am taking 0.9. Water absorption of fine aggregate, I am taking 2.5. Now, here it is my C analysis. See, from the left hand side, 20, 10, 4.75 and 2.36. First one is the C analysis of 20 mm aggregate, which is 98.8, 12.1, 0.2 and 0. And second one is C analysis of 10 mm aggregate, that is 100, 94.6, 2.3, 0.3. Here proportion I have taken 60-40. So their combined grading is coming 99.28, 45.1, 1 and 0.2. Now, if I make this proportion to 50-50, what will happen? See, on 10 mm C size, the percentage passing is almost just close to 55, 53.25, which is not good. So what I have to do? I have to reduce the percentage of 10 mm. So I am making 55. It is again 49, 1 and 0.135. If I make it 60, it is 45, 1 and 99. So you can see when I am changing the proportion of 20 mm, 10 mm, what is happening? Only 10 mm C size, it is giving more variation. Not 20 mm C size, not 4.75, 2.36. So according to this, the value is 45, which is in the middle of 25 of 50 and to 55. So this proportion is suitable for our concrete mixed design. Next one is C analysis of fine aggregate. Here The 600 micron percentage passing is 43.7. So the sand is in zone 2. Okay. After that, now we will go with the target strength. So target strength is our FCK plus 1.65 into S. The value of S for M25 is given 4 in the S456. So what we have to do? 25 plus 1.65 into 4. That is 31.6. It is our target strength. Okay. Next, water cement ratio. For M25 grade, water cement ratio maximum allowable is 0.5. So we can adopt, let's say, 0.485. Okay. 0.485 is less than 0.5. Hence, okay. Means it is satisfying the maximum water cement ratio requirements. Now, coming with the selection of water content. For 25 to 50 mm slump and maximum nominal size aggregate 20 mm, our water content is 186. If we use 10 mm maximum, 10 mm aggregate as nominal maximum size, the water content will be 203. And this 186 is for 25 to 50 mm slump. And what is our requirement? Our requirement is 100 mm slump. Means we have to increase the slump by 50 mm. So what we have to do? We have to increase the water. And how much? For each 25 mm, we will increase 3%. So for 50 mm, we will increase 6%. For 20 to 55 mm, 186 is given. And for next 50 mm, we are increasing 6% of water. That comes to 193 liter. Now, we are using a super plasticizer. So we are assuming that by using this super plasticizer, we'll reduce the water content by 11.5%. Okay, let's do not use the super plasticizer. Okay, we are not using any super plasticizer in a mix. So I make it 0. So what will be the my water content? 193. If I am using the super plasticizer and I assume that let's say 10% water will reduce, water demand will reduce by 10% when I use super plasticizer. What will happen? 10%. My water content reduced by 20 kg. Okay. See again, see friends, I am not using the super plasticizer. I am making it 0. The water content is 193. And according to 193, if you go with the next row, 193 divided by the water cement ratio of 0.485, our cement content is 398, almost 400 kg cement we need for M25. If we use super plasticizer and let's say reduce 10% water, our water content is 173. And for same water cement ratio, our cement content is 357. Means almost saving of more than 40 kg of cement, or you can say almost 1 bag of cement has been saved with the use of super plasticizer. 1 bag of cement is around 350 rupees. And what will the cost of admixture? It will be around 30 to 40 rupees in a cubic meter. Means we are saving around 300 rupees in a cubic meter. Okay. So 173 is the water content divided with the water cement ratio. Then it comes to 357, which is the quantity of cement to be used in mix. Or we can round off it. Let's say we can make it 360. Okay. Again, now we have the water. Water is 173. Cement is 360. Next, flash. We are not using flash here. I'm making it 0. So my cement content is 360. So 2 ingredients have been found, water and cement. Okay. Now coming to the coarse aggregate and fine aggregate. What we have? We have water cement ratio of 0.485. We have a volume of coarse aggregate 0.62 according to John 2 sand and 20 mm aggregate. Now 0.62 or 62% of coarse aggregate for water cement ratio of 0.5, and our water cement ratio is 0.485, means 0.015 water cement ratio has been decreased. So what will happen? We will increase the coarse aggregate and reduce the fine aggregate. So here I have given the formula. So 0.5 minus 0.485 into 0.01 divided by 0.05. So it will increase my coarse aggregate content. See, reverse effect. Now, if I choose water cement ratio of 0.5 here, what will happen? My coarse aggregate percentage will be same. If I increase the water cement ratio of more than 0.5, let's say 0.55, what will happen? My coarse aggregate percentage will reduce and fine aggregate percentage will go up. So taking back to our 0.485 water cement ratio, 0.485, (62% was the coarse aggregate percentage. Now corrected percentage is 60.623 or 62.3. Now for pumpable concrete, and we are not using pumpable concrete, so no further reduction in water or 0. So what is our percentage of coarse aggregate? Coarse aggregate percentage is 0.623 or 62.3, and fine aggregate is 37.7. Okay, now what we have to do? We have to find out the quantity of coarse aggregate and fine aggregate. Here, from 1000, we will minus the volume of cement, which is given here. We have the weight of cement 360 kg. We have the specific rate is 3.15. So if we divide 360 by 3.15, the volume will come 0.1143. Just like for water, 173 specific rate is 1 of water, then we divide, so it is 0.173. And in 1000, I am subtracting both values. So remaining volume is 0.713. Here you can see 77, almost 700 liter or 70%. 70% volume is to be filled by coarse aggregate and fine aggregate. Okay. Now 71.3% is the total aggregate volume. I have to multiply with the percentage of coarse aggregate, that is 0.713 into percentage of coarse aggregate 62.3. 0.623 and specific ratio of coarse aggregate 2.62. This is 1163 is the weight for coarse aggregate, And just like that for a fine aggregate, 0.713 multiplied by the percentage of fine aggregate, that is 37.7, into specific gravity of fine aggregate, that is 2.65. So here 712 is the weight of fine aggregate. Again, we have taken the proportion of 20 and 10 as a 60 and 40. So here 1163 multiplied by 60 will give the quantity of 20 mm, and remaining shall be the quantity of 10 mm. So here is our final proportion. What it is? Cement is 360, water is 173, fine aggregate is 712, 20 mm is 698, 10 mm is 465. Chemical admixture here, chemical admixture I have taken 0.5% of cement content. So it is 1.58 kg, and water cement ratio is 0.485. Okay. Again, what we can do, we can just slightly adjust the aggregates. So the just like that is 712, I can adjust to like 710. Here 20 mm is 698. I can write it 700. 10 mm is okay, 465. So these are our mixed proportion. Now next, what we have to do? We have to make a trial batch. Cement is 360 plus 0, 710, 20 mm 700, 10 mm 465, water 173, admixture 1.48 kg. Now, what? How we will make SHD condition? Here two terms, water absorption and surface moisture, I have taken into account. If my aggregate is dry, then I have to increase the water in the mix according to the percentage water absorption of the aggregate. If my aggregate is having moisture, then I have to reduce the moisture. Let's say my sand is having water absorption of 2.5 and total moisture of 4. I have taken the sample of sand and I won't write, and then find out that the moisture content of sand is 4%. That is total moisture content. So water absorption of sand is 2.5, means that 2.5% water of the weight of sand is required to the sand. It will take the water from the water we will add. If we are not increasing according to the water absorption of coarse aggregate and fine aggregate, they will absorb the water from our free water cement ratio and will not get the workability. If aggregate is moist, we are not subtracting the moisture of the aggregate. It will give the additional water to the mix, and our strength will go down, our workability will increase. So what we have to do? Check for the water absorption of the aggregate and check for the surface moisture. For water absorption, increase the water and reduce the material. Let's say my material is not having in water, surface moisture 0, 0 and 0. All material is dry. 2.5 is the water absorption of sand, 0.6 and 0.6 is the, or say 0.9, and 0.9 is the water absorption of the coarse aggregate. What is happening? I have reduced the weight of material here 692.25 and increase the content of water by 18 kg. Same here I have reduced the 7 kg of material, increase the 7 kg of water. Here I have reduced the 5 kg of material and increase the 5 kg of water. So my water was 173. Now my corrected water is 201.24. So out of 201.24, 28.24 is the water which is required by these three materials for their water absorption. Within 1 or 2 days of mixing, these material will absorb their water, and our free water cement ratios will be 173. Okay. Now, I am making the batch of 50 kg of cement. So I'm taking 50 kg. So for 50 kg of cement, my sand is 96 kg, 20 mm is 96 kg, 10 mm is 64 kg, and water is 27.9 or almost 28 kg. So if we go with the final percentage, cement is 1, sand is 1.92, coarse aggregate is 3.2, and water we know 0.485. So what is our final proportion is 1:1.93 is to 3.2. This is our concrete mix design proportion. It may change according to our requirement or water cement ratio or according to grade. Now we will conduct the trial for this. We'll cast the cubes and we'll check the cubes, and we'll check for the desired strength. Let's say if we are getting strength more than 40 or 45, we can reduce the cement content. If we are not getting the strength according to required target strength, we have to further increase the cement content or reduce the water cement ratio. So I hope आप लोगों को समझाने में मैं कुछ सफल रहा हूँगा. If any doubt, we'll have a Q&A session. Ankit ji?
Yes, sir. Yes, sir.
This is all
Please,
from my
you
side.
have. Yes, sir. Please, if you have any question or query, please
Can we take a
write
1
in
minute?
chat
Can I
box.
take a 1 minute break?
Okay, sir. Okay.
Yep.
If anyone has any query or question, please write in chat box.
Yes, Ankit ji, we can start with the Q&A.
Yes, sir. Yes, sir. Okay, sir. Some participants are asking for Excel sheet.
Yeah,
Can
I
we
will share
share?
to you. Yes, I will share to you.
Okay, sir. Thank you.
Any further?
No, sir.
See, actually, it's a wide subject field. Just 1 or 2 hours will not do good for us.
Oh, yes, sir. Yes, sir. I understand.
The students must have hands-on practical. वो लैब में जाके उधर ट्रायल अपना ये बैच बना के और ट्रायल करके they must see कि what is happening.
Yes, sir.
Then only they get to know what is concrete mix design. Initial stage, it is mathematical calculation. When once you go with it, it becomes hard for the person.
Yes, sir.
Till then, sir, you have tried to fulfill the expectations of the participants, and very nicely you have elaborated the things. वो जैसे मैं कहूँ कि वो गागर सागर को गागर में भरने का काम आपने इतनी देर में कर लिया. We know as a civil engineers, we all know that this is a very wide topic, but still you have done very nice efforts, sir. I must appreciate. And हम सब लोग मिलकर एक बार सर के लिए जोरदार तालियां बजा दें कि सर ने बहुत अच्छा काम किया है, बहुत अच्छे से सभी को एक्सप्लेन किया, बांध के रखा है सर. ओके, अंकित सर, प्लीज कंटिन्यू.
Yes, sir. Yes, sir. Now it's time for formal vote of thanks. I, Ankit Kumar Sharma, on behalf of Civil Engineering Department, FOECS, TMU Muradabad, and the entire fraternity of the institution, first of all, extend a hearty vote of thanks to our today's speaker, Mr. O.P. Sharma, for very interesting, informative, and interactive practice session today. Thank you, sir, for giving time from his busiest schedule to grace this workshop. Today, we had an opportunity to hear your views about concrete mixed design, new code of mixed design, IS 10262 2019, and we enhanced our knowledge. I extend my most sincere thanks to our director, sir, Professor R.K. Dwivedi, for providing us this opportunity. My warm gratitude to the convener of this workshop and our HOD, Professor R.K. Jain, for their guidance for well organizing this workshop. I am immensely thankful to all faculty members of our civil engineering department for their enormous cooperation, and many thanks to all participants. Actually, you made it successful and fruitful by sincerely attending all the talks. You are source of energy and motivation for us. Thanks for being with us. We look forward for such participation in our future events too. Please be in touch. Take care. Stay at home and stay safe. Uh,
Can I speak for 1 minute?
yes, sir. Yes, sir.
I am seeing that there are certain participants were joined from Pan India. Particularly, I can see Mr. Mahesh Tendulkar sir, Somnath Gore sir, Nishant Srivastava sir, and Yogesh VK sir, and certainly Preet Patel, Satish Moreji.
My request to all participants, please, if you switch on your cameras so that we can memorize this moment as a screenshot.
Yes, you can take. सभी मेरा रिक्वेस्ट है कि सब लोग वीडियो अपना ऑन कर लेंगे तो एक स्क्रीनशॉट हो जाएगा सभी के साथ में, हमारे ओपी शर्मा सर के साथ में.
सर आप लोगों के साथ में.
Thank you, sir.
So can we wind up now?
Yes,
if
sir.
anyone is interested, then definitely he can. It will be pleasure for us.